Okay, good morning. Welcome to
MathyMath number 102.
MathyMath number 102. So this is a problem from the 2012 AMC 10A. I'll give you a little bit of trouble this morning, and it's a really cool problem. A 3x3 square is partitioned into 9 unit squares, just like we've done here. Each square is either painted white or black, with each color being equally likely and chosen independently at random. The square is then rotated 90 degrees clockwise about its center. So just rotate it. And every white square in a position formerly occupied by a black square is then painted black. The colors of all other squares are left unchanged. What is the probability that the grid is now entirely black? Pretty interesting. Okay, so tell me a little bit about some of your thoughts on this problem this morning.
Well, I thought that I would split this up into cases.
Okay.
So, where 0 out of 9 start white, 1 out of 9 starts white, 2 out of 9, and 9 out of 9.
Okay. Just write 9 out of 9, that's fine.
Okay.
Okay.
So, and I noticed that these here are repeats of these ones here. Like, there's going to be the same number of things in these as there are in these.
Okay. Why is that?
Because it's choosing numbers. Because
Okay.
you're either choosing like 1 white or 1 black.
Okay, cool.
So, and I figured out to have this definitely not work for sure.
Alright.
You have to have a white square in the center.
Ah, okay. So if you've got a white square in the center, it never works. Why not?
Because you can't move a black square into the center, or that white square out of the center.
Okay, so it says that when you do the rotation, if a white square ends up in a position that was occupied by a black square, then you switch it to black.
Yeah, but since you're rotating the square about its center, this stays where it is.
That stays where it is. Okay, good. So if the middle square, so we've learned something. If the middle square is white, then it doesn't work. Huh?
Alright. Well, we can see that there's going to be some cases that don't work no matter what.
Alright.
Like, this case, nothing in here would fit the requirements because you don't have any white squares or blacks.
Okay, so the number is the number of black squares. So 0 out of 9, no squares are black. Okay. Alright, good.
No, no squares are black.
Alright.
And then here there's 1 square is black. At most that would give you 2 black squares.
Okay.
So that doesn't work.
Alright.
And here 2 squares, 2 squares are black. And at most this would give you 4.
Okay.
But actually it would give you 3 because you would need to have a black square in the center to have this work.
Alright.
And then this, you have a black square in the center, 2 other ones somewhere else. This would give you 5 and that doesn't work.
Okay.
Black square in the center, 3 somewhere else. This also doesn't work.
Ah, okay, good. So so you started out with 9 cases. How many are you down to now?
5.
Okay. And one of your 5 is actually...
started out with 10.
Started out with 10, you're down to 5. One of your 5 is super easy.
This one.
Okay, we know that one works.
So there's 1 case in it and 1 works.
Okay, there's 1 case there, 1 works. Alright.
Well, here this can work.
Okay.
But how many of the situations can work?
Alright.
So you have to have a black here. Is this corner will go to that corner.
Uh-huh.
This one's gonna go here.
Yeah.
This one's gonna go here.
Uh-huh.
And does this? No, because then you have these that don't work.
What do you mean they don't work?
Like these don't change
Why?
because you're rotating at 90 degrees.
Okay.
So this one goes to here. This one goes here. This one goes here. This one goes there.
Right. So why don't these change?
Because the black squares don't rotate onto them, or
What's the rule for when they change?
when they leave a position that's occupied by a black square, when they go into a position that was occupied by a black square.
Got to read the rule. A square is then rotated 90 degrees clockwise about its center, and every white square in a position formerly occupied by a black square is painted black.
So
Okay.
that means these would go up to here.
What would go up there?
These two white squares.
All right.
And they're in a position that would be formerly occupied by a black square.
Okay.
So this scenario works. Like, oh, the grid will be, well, will it be entirely black? No,
Why not?
because, well, because there's no black squares that are going into this area. Like, this is hard to explain, but
Yeah, that's why I want you to explain it, because this is going to help you understand the problem.
so these two squares go to these two squares.
Okay. So they change to be black. Okay,
Yeah.
good.
But these two are gonna have black squares in them,
Yeah.
and these two are still gonna be white
Okay.
because
So,
these two are going to were these two.
all right, so explain to me why this situation doesn't work now in a very simple way. Why doesn't this situation turn all black?
Because you have these sort of move out of the way,
Okay.
and these move up to here.
All right.
So these stay not black.
Okay. Which two? Mark them with X's. Where do they rotate to? Mark them with O's.
Here.
Okay. And those squares don't change. Okay, good. This is a good start. You can run off to school and we'll talk more about it tonight.